This is the video lesson for section 6.2. Before we begin that, I have a warm-up here in case you'd like to try these problems. It would probably be a really good idea just to see if you can get through each of these problems, as this covers all of the content that we learned in the 6.1 video lesson. So take a minute to go ahead and go through these. Pause me, because I'm going to go ahead and I'm going to tell you the answers for each of these problems. So for question number 1, you need to use the formula n minus 2 times 180. So n minus 2 times 180. I see that I have 6 sides here, so I'm going to plug in 6 for n, and my answer should be 720 degrees. Again, for 13 gon, I'm going to do the same thing, except I'm plugging 13 into n minus 2 times 180. So your answer should be 1,980 degrees. And for an octagon, I'm going to plug in 8 into that formula, and my answer should be 1,080 degrees. For question number 4, I first need to figure out what the sum of all of my interior angles is going to be. So I see that I have a 1, 2, 3, 4, 5, 6-sided figure, and we actually just determined in number 1 that I need 720 total degrees. So 720 total degrees. Oops. But I already have some measures here already. So I'm going to take each of these measures and I'm going to add them all up with my calculator. When I do that, I get 639. So I'm going to subtract 639, and that will give me my answer for the missing angle. So my missing angle should be 81 degrees. Okay, for number 5, what is the measure of one interior angle of a pentagon? So here, I'm going to take n minus 2 times 180, but then I'm going to divide it by n. And here, n is 5 because I'm dealing with a pentagon. So 3 times 180, and then that divided by 5, I get 108 degrees. And for number 6, what is the measure of one exterior angle of a nonagon? For exterior angles, my formula is 360 divided by n. In this case, 360 divided by 9 gives me 40 degrees. So now we're moving on to the lesson for today, which is section 6.2, Properties of Parallelograms. And you see in your objectives that you have 2 objectives. The first one says you can list the 5 properties of parallelograms. You are absolutely going to need to know those 5 properties. The next objective says you can use those properties to determine requested values. So the first thing we need to do here is we need to go through some vocabulary. So please make sure you get each of these words and examples written down into your notes. Our first vocabulary word is parallelogram, and a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So if I go ahead, I'm going to draw you an example here. This is just going to be a rough drawing. But I have here a parallelogram as long as I have the knowledge that both sets of opposite sides are parallel. Remember, we use these arrows to show that lines are parallel. So there I have 2 sets of parallel lines. They're my opposite sides of my quadrilateral, so I know this is a parallelogram. Now, the next word that we've defined here is opposite sides. So what I did here is I drew you a picture of your opposite sides being parallel. So your sides, if we number them like 1, 2, 3, 4 in that picture, underneath opposite sides, you know that 1 and 3 are opposite, and then 2 and 4 are opposite. And that's really just a little bit of common sense. Now, opposite angles are technically angles that do not share a side. Okay, now again, let's go up to our original picture and let's number our angles. We'll call them 1, 2, 3, and 4. And here my opposite angles are going to be angle 1 and angle 3, angle 2, and angle 4. And if you look at where they're located in the parallelogram, angle 1 uses sides 1 and 4. Angle 3 uses sides 2 and 3. So I have angles that do not share a side. Angle 1 is 1 and 4, angle 3 is 2 and 3. So now that we have our vocabulary, we can start looking at some theorems and some properties of parallelograms. So our first theorem is theorem 6.3, and it says, if a quadrilateral is a parallelogram, then opposite sides are congruent. That's important. Opposite sides are congruent is a property of all parallelograms. Opposite sides are congruent. I would underline that, highlight that, box that, something. That's important. So if I know my opposite sides are congruent, then when I look at this first example, I know that 5x plus 10 must equal 30. Then I can go through and I can solve this. Oops, I'm already doing mental math. So I subtract my 10, which gives me 5x equals 20, divide by 5, and I've discovered that x equals 4. So there's a you-try problem for you to go ahead and do. It's very similar as long as you know that opposite sides are congruent within each of these parallelograms. We have another vocabulary word that we need to discuss before we move on, and that's consecutive angles. Consecutive angles are angles that do share a side, or are that like they're right next to each other. So for example here, make sure you have this picture down, and then angle A and angle B would be consecutive angles. But so would angle A and angle D. So it's any angles that are right next to each other. Another example, angle D and angle C. Angle C and angle B. These are all examples of consecutive angles. So now using these consecutive angles, we have another theorem. Theorem 6.4 tells us if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This is the important part. Highlight it, box it, underline it, something. Consecutive angles are supplementary. That's a property of all parallelograms. Consecutive angles are supplementary. So first thing we have to do is we have to remind ourselves, what on earth does supplementary mean? So reminder, add to 180 degrees. Okay, so if I look at this first example, and I apologize, there should be an arrow going from 85 to angle C. So if I know angle C is 85 degrees, and I want to determine the measure of angle D, well, I'm just going to take 180 degrees and subtract 85. So I know that angle D, the measure of that angle, must be 95 degrees. And then I also have a you-try problem where I'd like you to find E and G, each of those measures. All right, so here we've got theorem 6.5, and this says that if a quadrilateral is a parallelogram, then opposite angles are congruent. Opposite angles are congruent in all parallelograms. So it's a very important property that you should have down, highlight it, underline it, box it, something. And I'm actually just going to give you a you-try for this one because I think you can probably figure it out. If I have two angles that are congruent, that means they must measure the same thing. So I'm going to set my expressions equal to each other. So you go ahead and try that you-try. Please make sure you have all of your notes ready for class tomorrow. Please make sure that you have scaled yourselves on your learning objectives, and I will see you in class tomorrow. Have a great night.